Okay, so today we learned how to solve absolute value equations when you have an absolute value on both sides. So let's look at number one. You're going to take the left side of the equation and you're going to set it equal to the positive right side of the equation. And then you're also going to set it equal to negative, and you have to put that, whatever's inside the absolute value, into parentheses. So you have to put a negative because that negative is going to be distributed to both of the terms that are in there. Okay, so to solve for j on this one, we're going to subtract 2j. It gives us negative j equals 3. So j is equal to negative 3. And then on this one, we're going to have j equals negative 2j minus 3. When we add 2j to both sides, we get 3j is equal to negative 3. So j is equal to negative 1. Okay, you should go back and check your solution. So absolute value of negative 3 is 3. 2 times negative 3 is negative 6, plus 3 is negative 3, and the absolute value of that is 3. So the first one works. Absolute value of negative 1 is 1. 2 times negative 1 is negative 2, plus 3 is 1, and the absolute value of 1 is 1. So if you go back and put those in, they both work. You should do that for all of them just to check to see that you got them correct. Okay, for number 2, we're going to do 3f minus 6 equals 9f. And 3f minus 6 equals negative 9f. There's nothing to distribute on that, so you don't have to use parentheses. All right, I'm going to move the 3f to the other side. You get negative 6 equals 6f, so f is equal to negative 1. And then subtract 3f. So negative 6 is equal to negative 12f. When you divide by negative 12, you get 1 half. You get 1 half, not 2. So you would want to take that and put it back in to verify that it works. Number 3, we're going to do b plus 3 equals 2b minus 2. And b plus 3 equals a negative parentheses 2b minus 2. You have to distribute that negative. So 3 equals b minus 2 when I subtract a b here. And then add 2. And b is equal to 5. Over here we're going to have b plus 3 equals negative 2b plus 2. I'm going to add 2b to both sides. 3b plus 3 equals 2. I'm going to subtract 3. So 3b equals negative 1. And b is equal to negative 1/3. Go back and check it to make sure that it works. And number 4. We're going to have 4h minus 2 is equal to negative 2, and you're going to put parentheses h plus 3. So you're going to distribute the negative 2. And then you also have to do the positive. Let's do the negative first. Oh well. 2 times h plus 3. Okay, so we have 4h minus 2 equals negative 2h minus 6. If I add 2h to both sides, get 6h minus 2 is equal to negative 6. Add 2. 6h is equal to negative 4. And h is going to be negative 2/3. I'm reducing 4 over 6 to 2/3. 4h minus 2 equals 2h plus 3. I'm going to subtract 2h. So 2h minus 2 equals 3. We're going to add 2. It'll give you 5. And h is equal to 5 halves. So we're going to go back and check to see if those work. All right, number 5. Your friend says an absolute value equation of absolute value of 2x plus 9 plus 7 is equal to 3 has two solutions because the constant on the right side of the equation is positive. So this friend is saying that um, since that 3 right here is positive, then the answer has to have two solutions, and we want to know if the friend's correct. But the answer is not correct. Your friend is wrong, and that is because when you subtract the 7 to get the absolute value isolated, remember you have to isolate first, and when you subtract the 7 you end up getting -4. So when the absolute value is by itself, it cannot be equal to a negative, so this would be no solution. It would not have two solutions. And you're done.